Hello everyone. So today's daily lead code problem is house robber. It's a very famous question. The question statement is saying to us that you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. Okay. First of all, we will understand what this question is saying to us. So, we are given an array, any array. We are given 5, 6, 7, 2, 4, 3. So there are six number of houses. Number of houses, six. Okay. Now the question statement is saying to us that these are the amount of money each house holds, and we need to rob maximum amount of money. But the constraint is that if we rob two adjacent houses, then a alarm goes on and the police will be informed. So the constraint is that we cannot rob two adjacent houses, two contiguous houses. So we need to escape one house in between to fulfill the constraints. So if we are taking this first 5, then we cannot take this 6. We can take this 7, but we cannot take this 2 if we have taken 7. If we have not taken 7, we have taken 2, then we cannot take this 4. We can take this 3. So for each possible number, for each possible house, we have two options. Either we rob it or don't rob it. Following the constraint that we can't rob two adjacent houses. So this is our constraint. Now what we can do, for each house we will have two options. Like for this 5 house we have two options. Either we take it or not take it. That means either we rob it or not rob it. After this we will, if we are take this, then we go to 7 and decide for this if we want to rob this or not. If we are not taken this, then we can go to 6 and decide whether we have to rob it or not. So, as you are seeing, there is some kind of recursion forming. Like if I have called this array, like for example, 1, 1, 2, 3, 1. Okay, these are the indexes of it. If I have called this function on this, okay, now after calling this, we have to decide if we are taking this rob or don't rob. If we have robbed this, then this will go to, the 1 will get added, and our index will shift to 2 forwards because we can't rob two adjacent houses. If we are not take this, then we don't get any money and our index will shift to 1. Okay, now for this f of 2, index 2, we have to decide whether we take it rob or don't rob. Okay, if we are robbed it, then we have 3 plus Now our index will be f of 4, which is greater than n, so it will return 0. So this answer will have 0. So our 3 plus 0, it is returning 3 plus 1, 4. So this answer is 4. And if we don't drop it, we have option of this index. Now out of this, maximum will be 3. So 3 plus 1, 4. This will return 4. And for this 0 plus f1, we have options. If we rob it, then this will go to 3. If we don't rob it, this will go to 2. Now for 3, we have option that if we rob it only, then the index will shift to forward. So 1, this will return 1. So 2 plus 1, 3. This will giving us 3, and 0 plus f of 2. If we have robbed it, then we have got, if we don't rob it, then so it will return 3, 3 comma 3. This will return 3, and out of this 4 and 3, we'll get our maximum as 4, which is our final answer. As here we are seeing in this, the output is 4. So we just have to implement this function. This is a 1D, this is a easy recursion. We can write the recursive function first, then we can optimize it accordingly if we are getting TLE or not. We surely will get TLE. So we just have to pass an index and this. Now we have to just check the end condition. If this happens, then just return 0 without any thought. If we are robbing it, then just add the amount of money to it and move to index forward, skipping one index, because we can't drop two adjacent houses. So it is as easy as that. If we not rob it, then we can add zero amount of money if we not robbed it, and increase the index by 1, because now if we have not robbed the current index, we can definitely rob the next index. Okay, so this is our implemented logic, and we just have to return the maximum of all the ways. So okay, and not rob. Okay, now we just have to return here this return f of, call this on first index and pass this nums in this. Okay, now we'll run this. This is the recursive way to do this. The test cases should get accepted, so they are getting accepted, as you can see. Now we will submit it. We will see that we are getting TLE, because recursive if calls takes much more larger stack space and time complexity, because they are calculating each things repeatedly. The things we have calculated previously are also getting calculated repeatedly. To avoid this, we use memoization. So we can implement memoization by using a DP array of size, initializing it with -1 each element, and pass this DP array in this, and pass this DP array in this also as a parameter. Okay, so now we just have to check if we have previously calculated then that should be not be -1. Then we just have to return this dp of I. We will not calculate it again, and we just have to store this max of drop comma not drop in dp of I and return it. So this is our memoization code, and we are here also we have to pass the dp arrays. We always forgot to do that. So the test cases are getting accepted, and we will submit this now. It should be accepted. Yes, it's getting accepted. So this is our today's code. It's a easy problem only. The category is saying medium, but according to me it's an easy problem of 1 ddp. So thank you everyone and have a nice day.